It's very kind of you, thank you. My briefcase, I've come with my luggage, and what's inside this case may be surprising. I came through Heathrow Airport with it yesterday, very, very concerned that they'd look inside. And they asked me, is what's inside if it was real? And luckily, so I was actually able to get here, I was able to say, no, it's a fiction. But the technology that it represents could soon be real, and parts of it are already. It's a technology that up till now has been imagined, invisible, or locked away in laboratories, and it's bringing design to a new space, that of living matter. Now, this technology is called synthetic biology. It's a new approach to genetic engineering, and I'm not a synthetic biologist. I want to make that quite clear. I'm a designer and artist and other things. And I first learned about this about 6 years ago. And as I learned more, it became clear to me that the aim of synthetic biology is to transform life, to transform biology into a 21st century design discipline. And what's inside this case is sort of the beginning of this story for me. So I'll start here. This is the International Genetically Engineered Machine Competition, or iGEM. It's a student competition that's held at MIT every year. 14,000 students have been through this competition in the last decade. And 5 years ago, I worked with a team of students at Cambridge University who are entering this competition. They decided that they were going to design bacteria that could produce different color pigments. So they designed standardized biological parts made out of DNA, inserted them into bacteria to make things like this, plates of bacteria that produce color. And they were able, over the summer, to produce a whole spectrum of colors. A whole spectrum of colored pigments. So this is a 3 months' work. It was absolutely amazing. And we called this project eChromai. And with another student, we decided to work with them to think about the potential of this technology, not just the applications, but actually the implications. And we used a timeline to get them thinking about the kinds of groups of people who might be affected by this technology, the kinds of laws and services that might emerge because of it. And one of the things we came up with was this idea that around 2039 you'd be able to go to the supermarket and buy a probiotic yogurt drink, and in that drink it would contain engineered eChromai bacteria. Now you'd drink the drink, the bacteria would colonize your gut, and they'd be engineered to detect the chemical signals of a variety of different diseases. And if they detected one of those diseases, they'd start producing the corresponding colored pigment. So I will now show you what's inside the suitcase, which I'm sure you've all been waiting for. We have, I'll put it up here as well. Yes, ladies and gentlemen, I brought coloured poo through Heathrow yesterday. I saw the guy at the X-ray machine do a double take. I was head in hands. So the idea behind this was cheap, personalized disease monitoring. It would disrupt healthcare as we know it. And this application isn't real, it's a fiction. You could call it a design fiction, an aesthetic provocation. We intended it as a critique. And we took it, we made this briefcase to take with us to iGEM, to MIT. And while we were there, we showed it to the students at the competition, to the FBI agents, to the UN bioweapons inspector, to the scientists and engineers who are designing not just the technology, but the frameworks that are around the technology itself. And some wouldn't even look in the suitcase. They thought it was too disgusting, even though they knew it wasn't real. And that was the point of this project, is we set it in 2039 intentionally, not to debate the technological possibility, but rather to look at the design and cultural issues around the technology. If this isn't what we want, then what do we want? And there's something interesting is that synthetic biology is talked about in terms of machines. This is the metaphorical language used around the technology. And as designers looking at this, we thought this was a really interesting interface, the gut. It sort of says much more about the complex and unique materiality of biology itself. So if you think this is just science fiction, that life is coming to our machines and our machines are coming to life and this isn't real, please let me introduce a lady called Pam Silver at the Silver Laboratory at Harvard Medical School. And her lab have just published a paper 2 months ago where They engineered bacteria to be eaten by mice, and the mice in their gut, this bacteria could detect and record the presence of chemical signals of different chemicals that were in there. The poo wasn't coloured, but they were able to take the poo, take the bacteria out, and detect these signals. Now, this research was funded by DARPA, the Defense Advanced Research Projects Agency, which is part of the US Department of Defense. Their motto is creating and preventing strategic surprise. And hopefully with this, I've a poo suitcase at a design conference, I've done that. But my question is slightly different. It's this: did our fiction come to life? Well, I've shown this project at science conferences a lot over the last 5 years, and I've seen scientists show slides of the work in their own work back at me, and as it's sort of shown as a design goal. But the DARPA research actually comes from a different goal. It was to be able to detect designed life inside people for biosafety reasons, but also to protect American intellectual property in an emerging global bioeconomy. And I think that's something that's really interesting. This has been called the century of biology, and the discussion around the ownership of life and how we're going to deal with that is something we're going to see a lot more about. This particular merging of reality and fiction, it may just be a coincidence. I'm not taking credit for any of the Silver Labs work, but I think there's a really interesting story in here about these sort of parallel tracks. So as these two worlds sort of begin to merge, of fiction and reality, of design and science, I think as designers we need to be asking, how do we start to think about the future in this way? 5 years ago, we would never have imagined that our fiction would become real so soon. And my question now is, well, what will synthetic biologists be designing 5 years from now? So my question ultimately, now what I'd like us all to think about today, is not what design can do, but what design should do. How do we move forward in this kind of design space? And ultimately, it comes down to this: what future do we want to design? Is design just a translator between emerging technologies and consumer products, or can design actually help us shape and influence the path of a technology? So to explore this a little more, I'll tell you a bit more about synthetic biology, and then I'm going to tell you a bit about the promises of the things that it is actually trying to do, the dreams it's promoting, and then I'll tell you about some of the ways that we're exploring this in the last 5 years. So yeah, the question to leave you with is, how do we design better? What is the better future? So this is synthetic biology. It's an early example made 10 years ago by students entering the iGEM competition. Synthetic biology is essentially design at the DNA scale. You can't see it, but its outputs could be visible. So the students here, they engineered a plate of bacteria so that the bacteria would go dark when they're exposed to light, a bit like photographic film. They called it E-Coloid, because as you might tell, all these projects have to have a good pun in their name. But today's synthetic biology is much more complex. This is an example of a yeast chromosome being redesigned and simplified. And the idea, ultimately, is to exert human control over biological systems, and the aim to be able to make biology standardizable, predictable, and programmable. But biology lives, and it dies, and it evolves, and this is a very different design space to the neat zeros and ones of computer logic. And that's the challenge for synthetic biologists. But the ambition is to be able to make fuels and energy and new materials, programmable gut bacteria, new things we haven't yet imagined. But at the moment, synthetic biology is doing this. Industrial synthetic biology is trying to make the same things that we already have, like making jet fuel from yeast, jet fuel from sugar, so that we can continue to live in the same way as we do today. To me, as an observer, what's promising to be a disruptive technology is also promising to disrupt nothing. And I think that this is something that we need to talk about. We need to actually understand how we can move forward from this situation. If we want to think about good design, if we're going to be designing the very matter, the same matter that we're made of, how do we begin to set principles for what is ethical or sustainable within this kind of design space? I'll give you an example of a project now, 5 years later, where I've been trying to work with fictions to explore this. last year, a conference was held between two communities who'd never met before, the synthetic biology community and the conservation and ecology community. And it was a bit like a first date, these two groups trying to work out if they had anything in common or if they were actually kind of mortal enemies. And it was a really interesting thing to go to as an observer, because to me, the biodiversity and conservation people are looking this way. They're trying to preserve everything that's ever lived. Meanwhile, the synthetic biologists are trying to create new organisms for the benefit of all humanity. And a lot of the discussions centered around, well, where do we go from here? One of the things that came up is that synthetic biology may want to save nature because actually it's a useful materials library for making new things, which is a slightly alarming way of looking at it. Meanwhile, the conservationists are concerned that if synthetic biology is released into the wild intentionally or unintentionally, like genetically modified crops are today, it may become their problem. But a really interesting sort of discussion within this was this idea of the sixth extinction. We're undergoing this great extinction event, and we humans may be its cause. So the dinosaurs dying was one of these extinction events. And the question came up was, could synthetic biology help save nature? Well, I thought this was a good question to make a design project about. So designing for the sixth extinction kind of came out of this, where I wanted to explore this issue. There's a strategy in conservation called rewilding. And that's releasing animals into the wild so that they can actually help sort of preserve and restore nature. And my question was, could we ever imagine rewilding but using synthetic biology? What would the synthetic biological wilds look like in this future? So this is the image that was in the gallery in the end. It's this sort of large, biodiverse, pristine forest. And as you start to look closely, there's some things that look a little odd, some organisms that you wouldn't expect. This is the mobile bioremediating device. It's a kind of slug that makes the soil less acidic, sort of countering pollution. Now, each of these, I decided to describe them only in terms of the patent application. So it's described as a machine, not as a living organism. And I decided to reflect the language and the real research that's going on in synthetic biology. There's a lot of talk about things like genetic kill switches as a way of ensuring biosafety. So I decided that this thing would kill itself after 28 days. This is a kind of fungus that would grow in trees to stop them to stop a disease called sudden oak death, and it would pump sort of pathogenic serum into the tree to preserve it. And all of these organisms would operate on a different DNA code, an expanded sort of six-base code rather than the 4 bases that we have today, A, T, C, and G. And that's also an approach that's happening in synthetic biology. This is a biofilm that would spread across the leaves to trap pollutants and viruses. And this is the autonomous seed disperser. It replaces lost mammals to collect seeds in its rubbery spines and distribute them around. It's sort of like a porcupine, but much better. My assistant really, she calls him Dougal. But he doesn't have a name because he's a machine. So power is generated for these machines by eating the other machines. And these machines operate in their own sort of closed technological ecosystem. And in the gallery, it was up on the wall, and this little girl came up and she was like, but what eats the big one? I was like, wow, that's a very good question. Will we have to carry on designing new things? And the aim behind this was to kind of get this conversation going of, if we're just making biological things and putting them into the world, will they have different rules? And ultimately, if we industrialize nature completely, will it still exist for us to save? So I released this project into the wild, and the internet bit back. I'm apparently going to save nature, and it was really interesting, the responses that came up. I liked 8% genius, but the point was to get this dialogue going. And the synthetic biologist, the language of this is really problematic because the image looks utopian, but the language is critical of the processes happening, and it sort of raised quite a lot of discussion, and hopefully this thing moving forward helps sort of identify how these fictions might work. But the fictions aren't the only way, and David mentioned that 2 weeks ago we took over the V&A Museum in London and staged a biological takeover. And I was invited to program the museum for one night and fill it with designs that explore the potential of biology. This was highly unusual because the V&A is, it's a repository of the world's cultural heritage. We had, in the atrium, we had a laboratory full of synthetic biologists. We had in the tapestry galleries, which are full of 15th century tapestries, we had textiles printed by bacteria. We had to freeze some of the works, so I had nightmares about the thought of the nation's heritage getting kind of blotches of pigments. And in the Raphael galleries, we had a resurrected vocal cords of a prehistoric animal bellowing across the Raphaels. And the questions in the context of the world's cultural heritage, this was the question we were trying to ask. Can we design life? How might we design life? And what might it mean to design it well? And these are the questions that have been fundamental to a project called Synthetic Aesthetics. This was the launch of our book, the culmination of 4 years of work for a project bringing together artists, designers, synthetic biologists, social scientists, where we were trying to take synthetic biology into the cultural domain. At the core of this project was a series of 6 residencies where we brought synthetic biologists together with artists and designers, and we put them in the lab and then in the artists and designers studio, 2 weeks in each. And that was the beginning of these collaborations that have been going on for years now. And our residents, we challenged them to think about this question of designing life, of designing biology, and crashing their ways of working together to find disruptive new ways of thinking. And I'll tell you just about a few of the projects to give you a sense of what happened and what's in the book. So yes, available here outside. Fanan is a plant scientist, and he worked with an architect, and they decided to look at the idea of the biological computer. So in synthetic biology, you program DNA to make computations. Instead, they wanted to look at the logic of the entire cell. Could we use natural logic as a way of solving structural problems, for example? So they kind of redefined the biological computer. We paired designers at IDEO, the design thinking firm, with scientists, cell biologists, and they looked at the actual design process itself, the way that ideas emerge and the creative process within science, raising lots of questions about the similarities that we see them as disparate things, but actually there's a lot in common. But it also raises a lot of difficult questions, I think, about the instrumentalization of life. And there's an unexpected twist, is that one of the biologists is now working at IDEO. So the idea of science crossing into design is something that I think we'll see more of. And I'll tell you about this one to finish. This is the pairing of a biologist with a scent provocateur, Sissel Tolaas, and they wanted to look at what they see as a potential conflict between the antibacterial, pasteurized world that we live in and a future powered by bacteria. So this is the human microbiome. We're covered in bacteria. Our own cells are outnumbered 10 to 1. And meanwhile, we're like blitzing everything with antibacterial stuff. So they started to look at where else these bacteria are. And I don't know if any Limburger fans in the audience. Hopefully no one's eating it now, because Limburger smells like feet. And it smells like feet because it's got the same bacteria, or a very close relative of the bacteria in your feet, as in the cheese. And so the logical next step was to see if they could make cheese from the human microbiome. Yes, I was the first speaker with stuff like this. So they made human cheese, and this was in the Science Gallery in Dublin last year. I curated a show, and we had Michael Pollan, we had Michael Pollan's belly button, and Hans-Ulrich Obrist's nose, and Olafur Eliasson's tears made into cheese. But it's actually really important cheese, because each of these microbial portraits actually tells a story about how we can't take things out of context. This bacteria taken out of context of the body and put into food suddenly seems disgusting. The same way we can't take design out of context and think of it as something that works in an isolated way. And the same lesson goes for synthetic biology. So all these collaborations are explored in this book, and each provides a stepping off point for a new set of investigations. And the book itself is a collaboration between 20 people across 20 disciplines, coming together with kind of opposing ambitions and opinions and trying to find new ways of working. And what's really important is that this project was funded by science. It wasn't funded by public engagement or arts money, and so the research is feeding back into the science itself. So this is kind of the question that I pose now is, if as designers we want to design a better future, how do we use design to do that? I don't think design just has to solve problems. I think it can ask questions, it can make things tangible and probe and investigate. I think design can help us understand whose better future we're designing. Our better future is a common goal, and I don't think we can just leave it to science or to government. It needs to be a conversation that we're having together. There isn't a right answer to this, no one answer. It's multiple problems that we need to look at. So synthetic biology is an example of a fictional technology. It's a technology full of promise, but this fiction may soon come to life. And as the contents of this briefcase show, its impact could be personal. And I think as designers and members of the public, which includes science, we all need to be asking, what future is it that we want? Thank you.
Daisy, that was wonderful. I've got to ask you, Daisy, have you actually tried any toe cheese?
I am very proud to say I have not, but people have. I had some Christina was making it in my kitchen 2 weeks ago in London. We actually swabbed not just her toes for the V&A, but also one of the lions at the V&A. So we made V&A cheese. So, but please don't try that at home. It's probably safe to eat, but you just need to be sure what's in it has been screened out.
So, quite a lot of what you're doing, I can see, has a benign idea behind it. I mean, particularly this project.
Yeah.
It's a benign idea because we can see that the opportunity is fantastic for low-cost detection of disease. But there's something of the dark arts, and there's something slightly worrying and scary about redesigning nature. And is there a bit of you that ever worries, actually, am I almost unlocking and encouraging and part of something that could be our undoing?
Yes. No, I think that's a really good question. I mean, I'm not promoting synthetic biology. I think that it's interesting to open up a technology and see if we can bring more voices inside it to actually direct it. But doing that, there's a compromise, is that I am part of the field, and my ideas, as I discovered, is that you may imagine the future, and by imagining it, it makes it more likely if you put that idea into the world. And if science is being this kind of science is funded by the military, by corporations, by governments. It's not, nothing is benign.
Yeah.
And I think that's, as designers, is something that we pretend or try to avoid thinking about. As we say, well, we have a brief, and my role is to fulfill this brief. And I'm asking if design can go beyond that and actually challenge it.
Minister Burzamaka was talking about the whole idea of interdisciplinary working, which seems incredibly relevant. That you would have almost thought that somebody thought to program that so cleverly afterwards. But this mix of design and science is obviously sort of, that's your métier. But so how are other scientists then actually relating to you? Is it a bit alien having a designer coming into their mix?
I think at first, when sort of 5 or 6 years ago, when I went into a lab, I said, well, I'm a designer, and then it was like, oh, you can do something useful, like design a website for us or help us communicate what we're doing. And that's not to say that designing websites isn't useful. But I think the opportunity here was for me to say, well, what can design be in this space? We get to define it. So by saying it's something troublemaking, problematic, difficult, and if the other scientists start to see the benefits of that and see how it can help them innovate and maybe innovate in a more ethical way and actually help define what that means, then I think it's hopefully is a good idea.
And I'd love to carry on talking, and I know that Daisy, I'm sure, is going to be around for lots of questions over coffee, but we now have to say thank you very much, Daisy Ginsberg.